This is section 1.4 and it's called graphs of functions. A real function is a set of ordered pairs of real numbers. It can be graphed on a coordinate plane in form xy or x fx. Remember that every x must have its own unique y to be a function. Now the x and the y, they have the domain, which is the x, and that's the independent variable, and then y, which is the range, and that's the dependent variable. Now here's my example of ordered pairs. Here's speed and then the distance that a ball is thrown in feet. Now the top set of numbers is the speed, and then the bottom is the distance. Now here's an equation that models this, and it's distance equals x plus x squared divided by 20. Now if you plug in any of these top row numbers, it will come out, the distance will come out to be these. So say you have a speed of 70 miles per hour, or 60, we'll do this. Say you have a speed of 60 miles per hour, you would plug in the 60 into the x's, and then out would come the distance, which is 240 feet. Now, you can plug this into your calculator. See here, you would hit y equals, and then you would plug in your equation, and then y1 would be your distance. And then if you hit trace, there you have it. I'm in standard form, or zoom standard, and that means that your domain and range, so your domain is -10, and then it can go up to 10, and then your range can be -10, and it can also have a max of 10. So here's the function, and then now for this ordered pair there's also a domain and range. The domain would be for speed, which they have from 0 miles per hour to 70 miles per hour. So you would put it in set builder notation, which would be a number, x, and another number in these little brackets. And the domain for this ordered pair would be 0 is less than or equal to x, which is greater than or equal to, or less than or equal to 70. And then the range, which is also in set builder notation, it would be 0 is less than or equal to y, which is less than or equal to 315. And that's because it can go from 0 feet to be thrown to 315 feet. And there's numbers inside of these two values. Now that I showed you how this equation can make a function, we're going to add in a second equation, which just showed up on there. Instead of using cx, which was my variable for this equation, I'm now going to use sx for x plus x squared divided by 12. And then if I go to my y equals, I put in the two equations. And then if I hit trace, it will come up on here in my standard fit graph. And it will have all the ordered pairs for their equation. And I can go on both. Now, these had all real numbers in this example, but there can also be problems with different numbers. There's natural or counting numbers, which are also real numbers, but it can be 1, 2, 3, 5, and so on. And then there's whole numbers, 0, 1, 2, 3, 4, 5, etc. And then there's integers, which is -3, -2, -1, 0, 1, 2, 3. And rational numbers, which is, it's different. It's numbers that can be represented as ratios with the form a divided by b, where a and b are integers, and b does not equal 0. So an example could be 0, 1, -7, 2/3, 1 and 9/11, and -24/10. And then there's irrational numbers, which are real numbers that are not rational. And that could be pi, which is 3.14, and so on. The square root of 7, square root of 10, and e. Now that's section 1.4.